Hi. So we've previously discussed setting up CIs, automating dependency bumps, attempting to automate merging of those bumps and why you probably don't want to do it, caching as a part of our pipeline to speed things up. Now, today I wanted to have a discussion about deployments and releases. Right before starting this video, wrote a little Twitter thread about deployments that was kind of a rant as well. I have been thinking for a while about how to get to this step, because whenever you talk about deployments, you inevitably end up talking about release artifacts. And when you talk about release artifacts, people like to jam the idea of I've released something together with the idea of I have deployed something. Now, if you are a one-person team or a very tiny team, there are many SaaSes that will provide, on Git push style deployments that really the aim of the game is to reduce friction, okay? And it's my personal opinion that deployment artifacts should be first-class citizens. So to clarify some jargon, what is an artifact? An artifact is something that we have produced. It could be, a compressed archive, it could be a container, it could be a binary, anything that we have produced for consumption down the road. Okay? So when we talk about making release artifacts, we're talking about having some build process that produces something and then stashing that away someplace. So what I did in a prior version of this video that ended up not recording was I took the time to make a Docker file for our project. And what this does effectively is it runs Rust 131 on Debian Stretch as the builder image. It sets the working directory as /build. It copies over all the files from the GitHub repository into that container, and then it runs cargo build release. After that, we switch over to an actual Debian Stretch image, and then from that builder image, intermediate image as they're known in Docker, we copy the release artifact into someplace on the path so that it can be easily run. Now, release artifacts, like we've said, can take many forms. And generally the process for deployments is that people will have at the very end of their pipeline some ephemeral step that basically just says, go off and tell Kubernetes about this manifest file that I've just kind of rigged up or that I've got locally. Or it might say something like, let's tell ECS, right, Elastic Container Repository, that I've just published this container image. There's also ways to set up kind of triggered things so that you release something on ECR and then ECR is tied to ECS and then ECS releases something. That's its own kind of individual thing. Different cloud providers are kind of pandering solutions towards that kind of approach. That's one approach. The approach that I prefer is that deployment artifacts, especially when you have releases that have versions, you don't want to tie your deployments to the versions of the artifacts that you release. You want to tie your deployments to something kind of tangible that is a moment in time. And the reason you want to do this is you don't want to make devs or operations people reverse engineer that ephemeral step that occurred at the end of a pipeline, right? It's like, it deployed with these settings, but then no one can find out what those settings are. And inevitably, to talk about the benefits of this, I have to talk about the benefits of infrastructure as code. So once upon a time, you had this notion of a Snowflake server or servers. And these servers were purchased and you hired people to take care of them. And the entire intent was that it was a snowflake, they were snowflakes, because you had to log on to them install things, munge stuff, provide upgrades, all on your own. Nowadays, cloud providers take care of a lot of upgrades. You do your own set of upgrades. But if you have infrastructure as code, Terraform, provisioning services, etc., you can just run code and it takes care of it. And it's about getting from this point of view from I'm going to do everything manually to I don't do anything manually, I let code do it. That's great for auditing. You know exactly what has occurred and what has happened, and if you have to ever run anything manually, you can have a manifest file that basically says so-and-so on this date and time ran this thing, so that people know, oh, well, okay, that's why there's this extra row in the table, or some, alter column that doesn't exist anymore, or whatever. Now, the nice thing about having deployment artifacts is you get flexibility with where you want to deploy, right? If you want to deploy directly back 3 versions ago, 3 commits ago, or whatever, you can just do that. The problem is that there's not a lot of services out there right now that actually provide this flexibility, but it's relatively straightforward to write something like this yourself. Now, what I did prior, after showing you this step, was we got it to build, okay? And after getting it to build, we raised a PR to basically include it into the repository. And now that it's a part of the repository, the thing that we were going to do was to focus on the release artifact side of things and to get GitHub package repository with a Docker image of a particular release. And when we have that, what we're actually going to get out of that result is a nice way to say, this is what I want released. Now, in that video that ended up not getting recorded, my user was added to the Docker group because I had just installed Docker. But the problem was when you add somebody to a group, that change doesn't take into effect until you've logged out and logged back in, and I haven't logged out and logged back in since starting this video again. So what we're going to do is try to get this going. 2 things that have to kind of happen. One is changing our workflow to actually start building this. Build Docker. So we want, as part of our pipeline now, to take the Docker file that we've produced that basically just builds our thing, right, and has it in an environment that it can safely run. And you want to be really careful about the container environments that you pick, because if you pick a container environment like, Alpine, and you build stuff on there, and then you come over to Debian, and you copy binaries over, it's very likely that things won't even work. And it's also very likely that if you copy or you build stuff like on Debian Buster and then try to build it on Debian Stretch, that won't work. If you try to go the other way, there might be breakages in the libc bindings or ABI changes, etc. So trying to keep things consistent and then choosing a particular architecture that's the same across the board for all of your projects. It's usually quite safe to pick some Ubuntu flavor or some Debian flavor that everybody's using and just stick with that. Weird little breakages can occur because of these things, and it's just something to be aware of when you look around and you're like, oh, why isn't this working? It can sometimes be differences between the underlying architectures that the containers are. And containers in and of themselves are their own kind of mixed bags of complications, right? There are pros and cons to using them. The pros are that it gets us a little bit closer to like this cattle-driven infrastructure where, we can just kill off servers and bring them back up with code, okay? And that things just get, there are clear templates for how things get structured. There are clear templates for how things get provisioned. There are clear templates for, individual releases and how they get produced. it's not, you want to get away from this world of people publishing stuff from their desktops. You want to get away from this world of, people kind of causing changes to the larger ecosystem or system itself on its own. And more into this world where everything is reproducible, independent of whatever the hell happens, right? You want to cover the case where everything is wiped out completely, and you can bring it all back at just a couple of commands, maybe even just one. Before we can even get to deployments, because I'm not even sure I have a good proof of concept yet to show you, but I'll link the Twitter thread in the description. But one of the approaches I kind of mentioned that comes from Charity Majors, she kind of goes, I don't actually recommend this approach, it's horrible. But it works, right? Is to have some cron job sitting somewhere on a server and it pulls down these things. And these artifacts, these deployment artifacts, mind you, they live, in a Git repository on S3. They live on Bigtable or DynamoDB or Postgres. It doesn't matter, someplace. And having a monotonically increasing number that they adhere to as well during publication meaning, publishing the deployment artifact someplace, means that even if you do switch over to using a service, a job or a script or whatever can basically ask this question, what is the latest thing? Okay? Why does this matter? Concurrency of deployments is important. And I have worked at many production systems where this has been a problem. System gets big enough. Let's say that there are a group of people that are doing dependency bumps all day and a group of people publishing code. Okay? The people shipping code, their build times for the whole pipeline are quite short. And the people bumping dependencies, because they have to do a fresh build potentially, right? We talked about this in caching. Their builds might take quite a bit of time or extra time. So here's a scenario. Developer A bumps a dependency. That triggers a change on master that runs. Developer B ships some code, and it's actually a bug fix that needs to happen ASAP. Developer B's change gets published, and that fires off some, again, ephemeral action for deployment. Let's say it just tells Kubernetes, please apply this as the latest thing. Okay? And Kubernetes is stupid, it's a computer. Computers are dumb, they just do what we tell them to do. It says, great, okay, I'm going to take that version and I'm going to roll it out and everything's going to be fantastic. Now, sometime later, developer A's changes finish and it does the same thing, and then it tells Kubernetes, deploy this version. And Kubernetes goes, great, awesome, I'm going to deploy this version, everything's going to be fantastic. And what ends up happening is you actually have deployed backwards in time, right? There's a causal relationship here that is actually more important. We want the deployment that was prior. Now you can fix this in a couple of ways, right? The few ways that you can fix this are, way number one, you always check for the latest build number or the latest thing before you do the ephemeral action, right? And that actually may be the approach I take here, okay, in these videos, just so that I can demonstrate deployments, just so that I can demonstrate, protecting against concurrency. And when you run that action, you say, go fetch the latest published thing, and that doesn't matter if it's what I just published or what I'm, or what, developer A published, right? But realistically, most CIs have some notion of a monotonically increasing build number on every single thing in a pipeline. And as long as you're not blowing away pipelines and bringing them back, that monotonically increasing number should be guaranteed to be there and should not exhaust within your lifetime. Let's just say that, okay? So the really important thing here is you have the idea of a release artifact, the idea of a deployment artifact, and the idea of something checking for the latest one, okay? And that way you cover the case where if somebody is, like the situation we described, potentially going to clobber changes, you've protected against that. Now, what's even better than this is writing your own service, the cron job, the script, the Flask app, whatever the hell it is, and saying, excuse me, I want to deploy now, and telling that external service, can you please, deploy this thing? And that external service goes, Yeah, okay, that makes sense to me. And then having that be the deployment mechanism, right? I think, in general, this is much more robust, but the problem is that it's now code that people have to look after, okay? So potentially just doing this check inside of your pipeline is enough for you. The alternative approach is you write a bot that handles all merges to master. Boars is a bot that I think was written in Rust, now is written in Elixir. You can add it to any repository you like. They provide free jobs and the like. And basically what it does is anytime that you raise a PR, you can't get a PR into trunk, into master, without Boars. And what Boars does is you tell Boars, I approve of this PR, it's good to go. And then Boars adds that to a queue. And then what Boars does is it tries to run its current thing against staging, right? This little staging branch. If that breaks because of prior merges, then it will report on the PR, I am sorry, but I cannot merge this into master because it will break master, right? And then you've got to go and fix things up and then, tell Boars again, yes, that's okay, try again. And you can even, Boars has this feature called tries, where you can not, as the reviewer, say, I just want to try this before telling the reviewer that to go ahead and approve. What this does, in effect, is put a synchronization primitive around any changes to master. And what's kind of nice about this is that if you put a synchronization primitive around any changes that go to master, you've now effectively described a really, really, really simple concurrency primitive, but you now have to force everybody in the team onto that workflow. And that's where this gets kind of icky. Your merge branch, like your main trunk history, is going to look fantastic because it's just going to be Boars going, I've merged this thing, I've merged that thing, I've merged that thing. And having that synchronization primitive at the merging step will kind of get you closer to what we talked about with deployments. However, it is not a full solution because imagine this scenario. Boars agrees to merge the dependency bump that developer A did, and then it agrees to merge the dependency bump that developer B did. And let's just say Boars is really quite quick today, and it merges A, and then it does to B, and it says, okay, cool, let me merge B. And then B gets deployed, and then A is still taking its time and deploys after developer B's changes, which are the latest ones, and then clobbers developer B's changes again. In the end, if this is something that matters to you, you're going to have to think about, please, how do I find the latest change? And this is where publishing a deployment artifact is quite important. So we've got about, I think we've got about 23 minutes left. So what I want to do today, after all that rambling and BS, is I want to get this Docker file that we've built building on CI. Now this is going to be icky because I think these are already container builds and running Docker inside of the container is a bit funky. So we might have to go poking around a bit and we may not actually get very far on this video. But I just, the end goal for this is to get the Docker file building and hopefully even publishing to to the GitHub package repository. If we can't get to publication to the GitHub package repository, we will do that in a following video. Okay. Bring in the cache. This is our Rust image. We will have to mirror this across to the weekly scheduled builds, but I kind of want to do another video another day where we explore if that's actually being triggered. And that's a good practice for just you have some infrastructure set up, now you need to debug it, you need to make sure that it's running correctly. That's a good separate video, so we won't worry about that today. We do need to find a Docker process or thing that will let us use Docker. So we need to find somebody that has this and what they are doing. So this is using JavaScript to run Docker stuff. How weird is that? Okay, Docker Action. The action publish Docker images to your repository. Can I please filter by amount of stars? No, I can't. There is this publish Docker one. Build Docker image. I don't want anything to publish. Okay? I don't want to authenticate anywhere. I just want to build. And the reason for this is that I have strong feelings around, people try to get clever around constructing CIs when really you should just focus on getting stuff to build and doing a lot of that. And resource constraints are something that you can face with other concerns. I know that people are money bound, but it sometimes helps to not worry about the money cost of infrastructure and to just worry about how can I reduce friction as much as humanly possible, because if I can't get improved bug fixes, features, etc. to the product immediately, this is the whole idea behind continuous deployment, continuous delivery, continuous integration, etc. If I can't get these changes there fast enough, that is potentially an issue for revenue streams. And if you're a small enough team size, like you're not some giant enterprise that's been around for a while, you're not Facebook, you're not Google, you're not Netflix, etc. You don't normally have to think about deploying, once a week or whatever, unless what you do is so incredibly crucial that any potential bug could cause catastrophic effects. Usually there is a need to kind of deliver a little bit sooner and put a bunch of stuff in place to kind of protect that flow. But fast systems incur usage, right? And fast systems mean that we can generally get away with experimentation, breaking things, building up, and getting stronger and stronger from that sort of growing process. Okay, so this one claims to have a Docker build latest. Okay, I just really want something that lets me run Docker, and that kind of seems like it will let me do the thing that I want to do. But yeah, I'm sort of fishing around here. Anything that's got PPR, VTag, KIND, Kubernetes in Docker. Anything that has a few stars, just so that I get a sense of the fact that this is run before. Dockerize. Docker lint, which is probably Hado lint or Hado lint, I'm not sure how you say it. Docker action, Docker publish Docker that has 136 stars, build tag publish Docker, suggest Docker tags to tag build, that's not even full sentence. So I'm getting close, I think, to just using. So there's this one, which is about publication to Docker Hub. Okay, I don't want that. This may be useful, right? For when we want to use the GitHub package repository. The authentication bit, I think, here. If we look at the authentication bit, if you are using a GitHub Action workflow, you can use a GitHub token to publish and consume packages in the GitHub package registry without needing to store or manage a personal access token. Okay. You can register using your GitHub username and personal access token. and the password is the token. So we could use this publish Docker thing to publish using the GitHub token here and just our, just another dot using it. Now, what publication is going to do is, I believe this will build. Okay, tag names. This action for Docker uses the Git branch as the Docker tag for building and pushing the container. Hereby, the master branch is published as the latest tag. Okay. This kind of goes back to the idea of what I was just mentioning about being clever or not. You have a workflow, and you have, let's say that you're a good code-based citizen, and your workflow consists of, I'm going to publish something, okay? Maybe on my branches, I don't publish anything, and I just build, and I just want to know it builds, okay? And then I only publish on master. If you've kept everything distinct, your release artifacts and, you've kept all of your deployment artifacts distinct, and you've made everything separate and kind of configurable and nice and flexible, what you will wind up with is an approach that means, do I want to publish on every single build, right? And quote unquote pollute, my package repository or whatever it is with a whole bunch of nonsensical things. In fact, this is kind of tricky because with GitHub package repository, there's actually a requirement that on public repositories, you can't delete any packages. Whereas on private repositories, you can. So for example, if you were to publish some release artifact that had a secret embedded in it or whatever that's exposed, well, you'd have to re-roll that secret. You'd have to kind of pull back from any problems. You'd have to tell people. That is its own issue if you're just constantly always exposing stuff or publishing stuff on a side branch. That said, it's kind of nice if you're always constantly building, because what you're doing is, if you're always publishing and you're always building and you're always publishing those builds, I know I just said the same thing twice, but if you're always doing that, you've amortized the cost. When we say amortize, we mean we've kind of swallowed the work up front so that we don't have to do it again later, right? By doing a bunch of work up front, we actually kind of save time down the line. Amortization is the same sort of concept that dynamically resizable arrays use. So if you have an array and it's like 4 elements big, and then now you have to go over 4 elements, well, you can duplicate, and now you only have to copy 4 things, and then you got twice the size, right? And then you go another 2 times the size next time, and you only have to copy half of the thing. And so each of these, since we're going bigger and bigger and bigger, and the halves are only kind of that big, right? They're not as big. It gets less and less frequent that we have to copy stuff over, okay? Same thing with doing local builds, because if you have something that you build, okay, and you're doing it all the time and you're just pushing stuff up, constantly pushing changes up to CI, then all that work that your CI is doing behind the scenes, right? You don't cancel any builds, you don't worry about that. All that sort of work that's happening behind the scenes then is paying itself forward, because maybe, you've pushed a change, that gets built, somebody reviews your change, they say this looks great, you merge the master, and now nothing has to be built, because it'll just go, oh hey, I already have that. Let me just, push this or tag this and then push this to the GitHub package repository. So we've got about 5 minutes left. I've spent a lot of time ranting, which is good, I think. I think there's a lot of sort of philosophical stuff here that we have to go over to kind of get at the meat and potatoes about what options there are, why you would want to do this sort of approach versus another approach. But if we can get this going before, what I am going to choose firstly, for this video at least, is to just get this running for now. Oops, there we go. Wrong keyboard. Don't need that. Don't need jobs. Uses, checkout master. Don't need that. Publish to registry. Okay, so there is this option to publish to the registry. And then there was this one too. So I kind of want to just show you how this would work, right? Now I actually don't know. Interesting. Actions Hub, Docker, push, build latest. I'm very curious now if we can get away with sort of just running, seeing if Docker is available on this thing. GitHub Actions. I want GitHub Actions, and I want oh, come on. I want the hash, the SHA. GitHub repository is the name of it. GitHub repository. Using environment variables. GitHub. Workflow, action, actions, GitHub repository, actor, GitHub shop. Perfect. That's what we want. So we are going to replace it with this. Okay, get rid of this guy. And I guess we might be able, I'm just going to take this out because we can plug that back in easily. And yeah, so the point is, I really just want to get this to be a step that runs and checks to see if anything builds. And I want that to be something that fails, okay? If things can't build inside of that container. And in fact, right, we've got test and build, and those things happen outside of the container, and that's great. But we want to get to a point where you could argue that you could only have the Docker image be the build. And sure, that would work. The problem is, oh, and it just works. Okay, so you have Docker available to you out of the box on GitHub Actions. Okay, that's great. We'll go a little bit over time here just to discuss something real quick. You'll see this building here, and these two guys have finished. This has pulled stuff. This thing is working on step 2 to 6. It's now running this thing. We're going to copy everything over. It's building cargo release. Hopefully that has the cache stuff because that exists locally on the image before it ran this. Okay, it finished this release in 7 seconds. It successfully tagged this. Let's go back to test build. Right, where was it? And here we go, actions and then the thing out. Okay. Awesome. That's completing the job. The last thing we will add is, no, that's fine. Test build is fine. We're going to merge that guy in. And then what we're going to do next video is we're going to get the publication to the GitHub package repository going, because that's actually quite straightforward now. I actually suspect that when you go to the packages section of your repository, if you are in the GitHub package repository beta, you see this. And my guess is that we might be able to really just run most of these commands. Like this tag name is what we had in the other one. And we may even just have it always tag stuff and then tag latest when it hits master, okay? And I'll have a lot of a think, I will have a think about a really simple way to demonstrate deployment in the future using this published artifact, okay? And we'll actually kind of squeak in this idea of publishing deployment artifacts as well to make that work, okay? Cool, so that's it. I don't think I've forgotten anything, so that's awesome, and I'll see you next time. Bye.